again, interval of convergence. Let's do our ratio test first. Limit n goes towards infinity. Absolute value, that's going to be 3x to the n plus 1 over n plus 1. And then when I do it, divide through by, 3x to the n, divide by n, but it's multiplying the reciprocal. You get n, 3x to the n. Let's simplify this a little bit. Limit n goes to infinity, absolute value n over n plus 1 times, what do you get there? You get, let's see, 3x to the, you just get 3x. And what happens over here is n goes to infinity, n over n plus 1 goes towards 1. So what do I get over here? The absolute value of 3x, and that has to be less than 1. So what does that mean? 3x is between 1 and minus 1, which means x is between minus 1/3 and 1/3. So I got to analyze again, these things, and if I can do that, it really doesn't look too bad to do. For example, if I analyze this endpoint, I'm going to get the sum n equals 1 to infinity, and if x is 1/3, I would get 1 to the n, which is just 1, and you get 1 over n, which I know is divergent, by the way, harmonic. Let's do the minus 1/3. I'll look at this one over here, and that's going to be n equals 1 to infinity. You're going to get minus 1 to the n over n, which I know is convergent. Again, you can do the AST if you want. I'm going to include this over here and write the interval down. What's the interval going to be? Minus 1/3 up to 1/3. The 1/3 is not being included, by the way. Again, there's work down over here, and I want to encourage you to look at the work if you're having trouble. But my goal here is to look at this and look what I arrived at. And I feel pretty good about that. Thank you.